What we're going to do here today is basically, hopefully, get you through four main things. First one, the evolution of Pasive House, and then what do we talk about when we talk about new typologies, and then give you a technical overview on how to tackle a new typology. And Marine is then going to talk to us about what does that imply into the design and construction process, and then we'll end up with a few takeaways. So the first thing let's start with the first Pasive House. I'm pretty sure you've already seen this slide many times. It all started with this residential project in Germany in 1991. And since then, we've gone a long way. We also talked about this yesterday. We are close to 39 million square feet of certified buildings, and 2.2 are from North America and Latin America. Equally important to having certified buildings is actually the monitoring that we all do after they are constructed and they're in operation. Monitoring helps us. It's the proof of concept that Pasive House works, right? We need to make sure that these buildings perform as planned, and this is a key part of it. So the challenge for us was, what can we talk about when we talk about new typologies? This could be, for example, technically residential buildings, but not multifamily homes. They can be hotels, they can be nursing homes, they can be student residences, or we can go into office and administrative buildings like these ones in Germany, or these ones in very, very hot climates. It doesn't matter whether they are large or whether they are very, very small, right? We can go a bit more complex with educational buildings, whether they're for children, very small children in many different places, or if they're also for primary schools, high schools, university buildings, or even for training of craftsmen. We go up a notch in the complexity, and we start with sports and recreational facilities, like sports halls, which actually have been around in the Pasive House community since the 2000s, early 2000s. But we can also even talk about leisure centers or indoor swimming pools. There's also centers for sports and culture, so we start with mixing up very different uses. So this is actually also a project where you have sports events, and this one as well, right? So this starts creating additional complexity factors into the projects that we need to take into account. We also can have churches, this is not a church, but and temples built to the Pasive House level, and that has different implications. And there are many other, right? We have museums in many different parts of the world. We can have fire stations, supermarkets, archives. We saw this in the plenary yesterday. Yes, with Jonathan, thank you. We could have factories as well, hospitals, or even also clinics. So how do we do that? In the large scale of things, it all starts with an idea, right? Someone wants to do a building to the Pasive House standard that has not been done before. So the first step, we start with research. I mean, we're a Pasive House Institute, right? So we start with a feasibility study. What does it imply to make this building high energy efficient? The second step, we implement that knowledge into pilot projects. These are the very first two swimming pools, which opened in 2011 in Germany. The third step is, again, we monitor these buildings. And then we put that into reports, and then we continue with the research to be able to make sure that these buildings work as planned, and also that we identify the best practices. Once we have these best practices, what we do, hopefully, is we set guidelines and we set tools and checklists for the next projects to come. And then my favorite part, the next step is more projects. So there's already the Exeter Leisure Center, which opened last year in the summer. And there are many more projects coming up with indoor swimming pools. So where to start? There's actually two very simple steps to do this, according to us, at least. The first one is identify or learn about your building. So what are your boundary conditions? Is it going to be a typical Pasive House with 20 degrees centigrade? Sorry, this is in SI units in the winter, and 25 degrees in the summer? Or is it has different? Does it have different requirements? Is it going to operate 24/7 during the entire year, or is it just going to be open for a short period of time during weekdays? Then, when are your occupants in the building, and what do they need to be comfortable in there? And then once you have that, you have to think about what processes are in that building, or which services are there, right? Not only hot water, ventilation, and so on, but also maybe you have additional equipment because it's a very specific use. So we have to identify that mainly for two factors. The first one is you will have internal heat gains, so you need to deal with those. And the second one, your primary energy. So once you have that, the next step is super easy. You have to set targets for high energy efficiency for each of these services. And if there are no requirements yet in terms of Pasive House, then you can draw these targets from recommendations from previous projects that are Pasive House, or you then have to do an additional step, which is you take a look at a typical building from that typology, and then you identify what are your main contributors to the energy demand, and then you start finding solutions for energy efficiency. And that's it. That's all you have to do for any single building. Okay.
So we don't need the rest of the presentation.
Yeah, exactly. We don't need the rest of the presentation. So going a bit into more detail into what that entails, it's basically, first, you start with your Pasive House basics. What are your strategies to reduce heating and cooling? We're talking about very high quality thermal envelope. We're talking about ventilation, probably with heat recovery, very good air tightness, and then to think about what you're going to do in the summer. Cooling, passive cooling, active cooling, and then how do you make that work properly if you have intermittent operation? Same goes for ventilation. Guarantee a very adequate air volume, and then think about where is your air coming in and where is it going out, and then how to make it work when your occupants are in the building. Once you've targeted these first two steps, which are more or less the same for all Pasive Houses, then probably the next big contributor would be hot water, then lighting, and then we start talking about the nitty-gritty, tons of additional specific end uses for each typology. It would probably be the case that because these new typologies have so many, they have a lot of equipment that they probably would not be able to be certified under the typical Pasive House criteria, right? So there's already a provision in the criteria for that, don't worry about it. But what it does require is that we develop bespoke targets. So a very important thing to note is that we have bespoke targets when the typical Pasive House criteria is not physically achievable. But the approach and the goal is the same. We need comfortable buildings, healthy conditions, and minimum energy use. Okay, so once you've done your building, it's constructed and everything, especially for complex typologies, we need commissioning, and we need to take a look at how the building is operating. This is an example from some of the pools. The red line that you see to your left is where the average of the energy consumption during the first year of operation. The second line on the right is the average of the operation once they took a look at the controls and made sure that the building was actually working as it was planned. This is a difference of 60% in electricity for that building, right? So once we've done all the work of planning a Pasive House and making sure that everything that is installed there is efficient and that we have a very high quality thermal envelope, let's make sure that it works the way we thought it out. And then once we achieve that, we collect data, we share lessons learned with our community, and then in this way we have improved best practices, or we improve the best practices so that the next buildings are even better than what we started with. Okay, so What we are going to try to do now is go through a couple of examples of building typologies and hopefully give you an overview of what you need to think about to do them. Because I started, I will just give you the easier one, which are schools, right? Typically, schools work the same as other passive house typologies. So you would set 20 degrees centigrade for winter and 25 degrees centigrade for summer. If there are sport halls, then maybe the temperature needs to be 80 degrees. For passive house, we already work with standard values for internal heat gain, which are different if the school works a full day or half a day operation. We know that they are not operated 24/7, or most of them are not. They are closed most of the times in the winter. But what this means is that we have a high intensity of use, but only when the students and the teachers are there, right? So we need to think about having a very good air quality and a very good ventilation strategy that is coupled together with the heating strategy, but only when the occupants are there. There's no, we're wasting energy if our building is working when we have no classes. So how do we make that work? It's very important to think about that when we are designing the systems. And then there might be some special requirements, fire protection, as we all have, and then safety, because, I mean, schools are for children. We need to make sure that they're safe there. In terms of primary energy, it may only need a bespoke limit if you have a canteen or a commercial kitchen, but Marina is going to talk a bit more about that part. Just to give you an example of the implications of intermittent operation, this is a very basic exercise. Let's say you would set you want your ventilation system to work with 25 cubic meters per hour per person. If the very first example at the top is the amount of energy that we need for heating in red, and the amount of energy that we need for the ventilation system to work, if we set it up to work 24/7. We obviously don't need that for a school. So what happens if we cut that to 15 hours a day? That's already roughly half of what we had, right? And then think about it even better. What if we only have ventilation on demand? Then we further reduce the energy that we need. And then what if we start thinking about optimizing the air volume depending on the occupants that I have, and then working better on the controls for demand? Then we can reduce it even further, right? So we've come a long way from the 24/7 operation up until the most optimized one. The level of complexity of your system will have to do with how you want to deal with it afterwards. So like these three options below have implications in terms of who's going to operate those systems and so on. So you also have to think about that part. Hospitals, in a nutshell, these are slightly different because we have people there that are recovering from a disease or that need treatment, right? So our requirements for comfort are higher. And not only that, but we have very specific requirements in terms of the quality of the air and the fact that we need sterile areas, right? We cannot have humidity issues in hospitals or any of these things. The operation would probably be 24/7, so this is a very energy-intensive use. And on top of that, there's all the equipment that we need to make a hospital work. So you need to think about all these different services that will be there. So what are 4 things that we need if we are working on a hospital? First, there must be like a specialist that works only in hospitals in that project, and you need to make sure that this person understands what's Pasive House as early as possible, right? That is your key partner in this journey, so to speak. Then what we talked about already. Look at all the energy uses, even those that are not typically included in an energy balance, and then find ways to make those more efficient. From the experience from the hospital in Frankfurt, we know that you can reduce the energy demand from this type of buildings between 40 and 50% compared to a new building, and even more if you compare it to existing hospitals in Germany, I guess. One of the challenges that we will face is that probably for this very specialized equipment, there will be no energy label. right? So there's no way to easily compare what's efficient and what's not efficient. So what we have to do is basically take a look at what is driving our total energy demand. Let's start with heating, the red part at the beginning. So these first 1, 2, 3, 4 parts are typical for passive houses that we said we will start with. So let's say we already worked on heating, hot water, ventilation, and cooling. What are the next big energy consumers in my hospital? Well, first one, lighting, because it has to work 24/7. The second one, IT and communications, which is needed these days for every single building. The third one, the commercial kitchen. And then actually from that on, there's hundreds of equipment that need to, in theory, you should take a look at. But in this case, it was identified that the things that you need for sterilization and then the MRI were the two ones that were basically taking up a lot of energy. So the other, once you have all like these elements that are, I hope, less than a dozen, then the other 14% is still important, but it's not your priority because you already tackled the main ones. And that's basically how, or ideally what we should do with each typology. And now, Marine is going to talk to us about commercial kitchens.
Okay, thanks, Elena. So same thing with the commercial kitchens. We've worked on them long enough now to get an understanding of what are going to be the key levers, what we have to look at when we're faced with them. So again, in a nutshell, where do we start? Here we go, that works. The first question is around occupancy. So these kitchens, they're not going to work 24/7. So we're going to want to account for that and make sure that all the equipment is set up to meet that occupancy profile that is not 24/7. The next culprit, or literally the biggest culprit in a commercial kitchen, is always about ventilation. And it's actually driven by exhaust ventilation needs. And these needs are defined as a general term by your entire kitchen layout. So there's a lot of things that go into that will then set how much exhaust requirement you need, as well as the efficiency of your kitchen exhaust hoods. So if you're already working on these, you're starting from a very high point and going better and better and better every time you improve on these items. The second thing that Elena already mentioned in this call is, of course, that demand control ventilation. So it's one thing to have a system that does not work all the time, but clearly doing it on an as-needed basis, because, for example, cooking prep, which is just washing and cutting vegetables, is very different from, going all in and frying how many, pieces of chicken you need for your meals, right? So that is a very, very big lever into the commercial kitchens. Another one that is interesting is questioning if let me rephrase. Your needs are driven by your kitchen exhaust requirements, but of course your kitchen exhaust needs to be matched somehow with makeup air. And the big energy penalty that we're paying is to condition that makeup air that is coming from outside, right? And so the first thing to do when you've done the biggest stuff before, it's also to question, do I need to condition that air or not? Because in some cases you might, in some cases you might not. So of course, be careful of kitchen staff comfort, that's super important. But we've seen in certain cases that a portion of that makeup air didn't need to be conditioned. So then you win and you're only paying for the fan energy rather than heating all that air from outside temperature to whatever set points you've got. And finally, heat recovery if possible. So this is clearly not, a straight shot, but definitely maintenance and fire risks are the two to consider. But we've seen it with simpler heat recovery systems that are less efficient, but still much better than a 0% heat recovery efficiency, that we can keep carving the energy down once we get to use these systems. Big culprit number 2, kitchen equipment, as you've guessed, because clearly we're putting a lot of those, and they ask for a lot. Where are we at right now? I am really pleased to say that we've been working on commercial kitchens, I want to say, for the last 6 years now. And the market has transformed so much that it is definitely feasible to ask for an all-electric kitchen, which wasn't the case a few years ago. So that's great. Of course, common sense will dictate high performance equipment, but that also, don't forget about like your whole refrigeration system, walk-in freezers and whatnot. And recognizing that as much as we want the best of the best, you will be tied to what the industry is putting out in terms of equipment. Right? So as much as we're pushing for innovation, I think that, for example, Europe and North America are not exactly at the same spot at the moment. Okay. So we can ask for it, but we might not always get everything. Finally, culprit number 3 is going to be domestic hot water. Just, need to account for that, because through, all the cooking portions and the cleaning, it adds up. So worth noting that. And so, more or less following up from the domestic hot water, what is really interesting in these typologies is looking at the sources of waste heat, because there's a lot of them. Just to name a few, only in the kitchen only, the heat that you're going to extract from your refrigeration system, from potentially also cooling the air, because these spaces have a lot of internal heat gains. Wastewater as well from dishwashers and others. They are a lot of waste heat sources available, and you need to understand if there is any synergy between your waste heat being available and you needing, more domestic hot water. So in the kitchens that we've done, we've seen, we've been able to reduce the total energy consumption that we've had by providing a significant portion of the domestic hot water preheating, thanks to our waste heat sources, okay? So that's really interesting. And finally, the PER requirement that we're meeting, it's based on an additional PER allowance, which is based on a per meal metric. So we want that idea of fairness, and it's not about how big your kitchen is or, TFA or something else. It's about the service that you're delivering. Therefore, you're working on a per meal metric, which will include all your kitchen equipment, including your big fridges and stuff, your refrigeration system, and the kitchen domestic hot water demand. Okay? Your ventilation is obviously already captured into your space heating demand, right? So it's captured there. And so just to finish on the commercial kitchens, this was a graph of the, actually from PHI, from the research that was done before some of these kitchens, some of these projects were designed. And what I want to highlight is so really good research, which guided a lot of what we've done. But second, when we look at the benchmarking of where we are, the industry standards that we've looked around in the US and in Europe, we're really in that 4 to 5 kilowatt hour per meal. And at the moment, so Elena already mentioned this, we don't yet have monitoring of these projects, but we have, the whole design and construction phase is completed. The current numbers are between 0.25 for a cold meal to 1 kilowatt hour for a hot meal in terms of final energy per meal. So you can see that the impact that we can have on the industry in terms of improving that typologies is just huge, right? We all know where commercial kitchens are, like all the restaurants, cafes, and whatever. So definitely a lot of impact there. Okay, I'm going to pass it to Jessica for the supermarkets.
Thank you, Maureen. So we're rushing through all of these typologies and giving you a bit of an insight of what you can do to improve the efficiency and get to expected passive house levels. I get to speak about 2 typologies, starting off with supermarkets. A number of these projects have already been implemented. It's an interesting typology, diving into the details. And again, you start with understanding what is the building about, what is passive house supermarket in a nutshell, what do you need to look out to drive down the energy demand. Starting point, as usual with Passive House projects, is looking at Passive House quality for the thermal envelope, looking at Passive House ventilation. There's no big secrets in there. It's kind of a Passive House conventions that we're used to. And for supermarkets, for designing the envelope, we look at standard internal heat gains. So we have standardized internal heat gains that we use as boundary conditions to define the quality of the envelope. Now, the important thing for the supermarkets is that you look at everything that is within the building that is an energy consumer, as we did also for the other typologies. And when you look at those numbers, what becomes really important, heating and cooling of the building is fairly minor. The big drivers here really are the refrigeration equipment that you have within supermarkets to provide all the fruit, all the food that we have within supermarket. That's a big driver. You see a pie chart here that's taken from literature, actually in the Californian context, where you can see it's actually over 50% for the refrigeration, and we see that also reflected in other literature and monitoring data. So that's really what you need to be looking out for. The other thing is things that we know also from other typologies. Lighting is a big driver. That's often on 24/7. You have to be very careful. In supermarkets, there's a lot of potential looking out for daylighting, but also being aware of how do you present your products to the customers. Those are discussions to have had in the context of any retail or supermarket projects. And then also the ventilation, electricity. We're not going to dive into the details of how to drive down the refrigeration energy demand. There's a lot of potential in there in terms of the cooling equipment you use, in terms of the actual cabinets to display the food. On the order of magnitudes, it's about 50% that we think we can drive down the cooling demand for these refrigeration equipment, basically. Another interesting aspect is that you want to use the waste heat from that refrigeration to be able to provide heat to the building and not needing any additional heat source. An interesting factor here is that when we look at our energy criteria, it's no longer a valid reference to look at the TFA of the building. What you want to be looking at here is that the energy requirements scale with your total display area of your refrigeration, right? That's what the main energy driver is. And the opening hours also factor into that. So we have some guidelines from PHI in terms of how we certify, how we accredit Passive House supermarkets. We define the criteria, as I said, scaling with that display area and the opening hours. To give you a brief insight, there's a number of projects. This is hugely popular mainly in Austria. So out of our offices in Austria, one of our colleagues is doing a lot of supermarkets, one after the other. There's the one chain in particular, Empreis, that's just really adopted this and says this makes so much sense to us in terms of bringing down our costs and providing good quality that they've adopted the Passive House standard for all of their supermarket buildings. So this is just a selection from the projects in Austria. Moving on to the next typology, indoor swimming pools, and I'm going to ask you to stop if I speak too much. This is a topic I can speak about a lot. One of the areas I've done a lot of research in and I've worked on since those first projects in 2010, 2011. So leisure centers, I'm going to try to keep it as short as possible. In a nutshell, this is a whole completely different story because we're dealing with much higher temperatures. We're dealing with very high humidity within the building. We're dealing with, if it's a leisure center, very different conditions with one and the same building. So you have your pool hall, which is very, very warm. It's 32 degrees Celsius. So what did we say? 86, 87 roughly in Fahrenheit. The wet change is going to be a bit colder, and then your office space is even colder, and then if you have gym within that facility, that might even be cool. So you're dealing with all of that within one building, within the same Passive House thermal envelope. So that's something we have to deal with. There's also high energy demand for hot water. The showers, obviously, but not only that, there's that whole mass of pool water that we're keeping warm all the time for the people to use. That's one of the biggest facilities within the project. So that's a big energy driver. There's aspects of pool water evaporation that brings in a lot of humidity into the space that we have to deal with, but that also brings heat losses. All of that evaporation draws heat from the hot water. So those are things we need to look out for. We have water treatment equipment that runs 24/7 to circulate that water in the pool, which is very energy intensive from the pumps, to make sure it's filtered and it's clean. So that's another thing to look out for. And then often there's a lot of add-on facilities depending on the complexity of the project, whether there's saunas or additional spas or gym. It really depends on the project. So there's a lot of variety in here. We're often also dealing with very long opening hours. These projects open at 6, 7 a.m. and are open quite late if you have sauna spa facilities. So again, that has energy implications. So the process at the moment in terms of how do we define what is actually a passive house leisure center, passive house pool, it's very difficult to define one number of your energy criteria because it depends so much on what is actually included in the project. So it's bespoke criteria, bespoke heating, cooling, and primary energy requirements that really scales depending on the pool size, depending on additional facilities within that project. And that's something where we've built on our learning from previous projects and are streamlining that more and more for ongoing projects. In a nutshell, so far I've kind of highlighted what the boundary conditions are, what we're dealing is, what does that actually mean in terms of solving it, how do we approach it. Passive house thermal envelope is an absolute starting point. It's a no-brainer anyway for all of us in this room. The interesting point here is that for a pool hall, it's even more important because we have these high temperatures, but we also have the high humidity levels. So you really want to be looking out for those details at the windows, the window installs to avoid condensation. And that's where all our passive house experience gives us a huge benefit. For these pools, we can allow higher humidities, which is an energy saving measure without running into risk of damaging the envelope. You also want to be looking at zoning within those buildings because we have different temperature requirements within. Looking at reducing evaporation is a bigger important aspect, looking at the efficiency of the water treatment system, so the pumps, the filtration system, having demand-based energy efficient ventilation, as Elena had already pointed out, also for other typologies, it's also extremely important for this typologies. Lighting, I think is something we have to learn more about and be more consistent or be very insistent to have efficient fixtures, but also have good controls for our lighting systems, something that we need to be looking at across all of these different typologies. Heat recovery from wastewater is another one that you can look at. And then looking at efficient heating systems and potentially using waste heat from part of the building that you're cooling to heat other parts of the building for an overall kind of efficient system. And these projects that we're working on are often working with heat pump solutions, which is very, very promising. So just to give you an idea of the energy balance, this is from one of the monitored projects, one of the ones in Germany. If you look at the energy bar on the left-hand side, we have our heating consumption, on the right-hand side, the electricity, and the big driver really is the pool water heating, it's the space heating, and then on the right-hand side from the electricity side, it's the water treatment equipment that runs 24/7 that really is a big driver. And this is already passive house level, so this is already a lot reduced compared to a conventional building. Passive house modeling for pools also becomes a bit more complex in a way, because we have all of these different temperature zones, so you're going to have to work with a multi-zone PHPP approach. Without going into details now, if you do want to learn more, then maybe something to speak about offstage afterwards. And we also need additional calculations. All these aspects of the pool water heating are not in a conventional PHPP. So over the years, we've developed the so-called maybe working title pool tool, which does an energy balance for the pool water heating system. So that's an add-on calculation that you're going to have to do. For these two pools in Germany, the pilot projects, we achieved savings. So again, important to do monitoring, have proofs of concept. We're talking about 50-60% for the heating demand reduction. And then electricity varies depending on your project. But yes, we're in that range of 50 to 60% EUI reduction. There's a lot to talk about for pools, to go into the details, and there's a lot more information available in terms of how you can actually implement this, what your efficiency technologies are. For this typology, we have a very detailed guide that's available both in German and in English that is available for free via Passipedia, where you can take a deeper look if you want to learn more about this. And with that, I hand back to Maureen. Thank you.
Okay. Thank you, Jessica. Okay, so we've seen a lot of different typologies. We've given you like years and years and years of research in like 10 to 15 bullet points. What we wanted to do today was look back at these different typologies. We've approached them in different ways, but trying to see if there is a recipe to approach any other typologies that will come to the passive house world. And so we looked at the process. So now we're not looking at a particular typology. We're just trying to see what were the steps that we had to do to get us there. So I'm going to pick it up exactly where Jessica left it. The first thing is do your literature research, because you will not, you are not setting up your project for success if you don't understand the typology. So where do you start with? A lot of literature research with, a lot of the resources. Jessica showed the one for the swimming pool on the right. We have that for some of the kitchens, airtightness testing in high-rise buildings. So there's a lot already out there. Protocol bands as well, hidden somewhere, but it was super useful for the kitchen as well. Then you have Passipedia, where PHI also feed into that database. And one that is extremely important is the one around non-residential passive house buildings. And that's a starting point for all the typologies listed on the screen. And then there's still a lot of other sources, right? Conference proceeding, we've always had them for years and years. It's always worth digging back to see where other teams left things at. Of course, other technical resources, because in North America, we have a lot of publications through ASHRAE, DOE, NRC, like both sides of the border. And worth looking at the latest work that some of the universities are doing, because more or less we're writing a lot of theoretical articles, but some of the universities get to have extra funding to do some of the things, in the lab, and they are helping us move these typologies forward. So literature research. 2, again, 1 and 2, I cannot overstate enough. Reach out to experienced teams. Okay, I think that stepping back after 15 years in the Passive House community, I think that our community is one of the most open ones that we have, and are always willing to share the lessons learned, the good and the bad. And so I think we should really use that. So what does that mean? You do have the Passive House database, you have the articles. Quick shout out to the Passive House Accelerator as well, putting so much good content out there. But go further, okay? Trying to go on a building tour, trying to talk to the teams that have been in the middle of all of this, because we will probably welcome, a quick conversation. And I see it more and more. I've even seen it in a couple of RFPs actually in Canada, where when we have inexperience, I want to be really clear, inexperienced in Passive House. Okay, they're very experienced, but they haven't done some of these difficult typologies at a high performance level. Then it is a requirement for them to go talk to or hire one of the other firms to give them just a little bit of feedback, right? Because when we have an experienced team, the path is going to be 100%, much smoother. And of course, get in touch with PHI, okay? Because you've seen through all the typologies we went through, this is still very project specific. So make sure you start that conversation early. 3, we need an exhaustive understanding of the typology specific energy uses. So what do I mean? What I mean is that for the project that you're going to work on, it's one thing to say, in our case, it's a commercial kitchen. I know you're going to cook a lot of things, but you won't be able to get proper optimization of your energy demand if you don't understand in granularity what is happening. So spend the time really early to save yourself a lot of trouble down the line. And the second one is we, again, as energy consultants, we tend to be maybe a little bit shielded from the owners, where might not be right in front of them, let alone the actual building staff that will be there and operate the building. And if they're not part of that conversation, what you're going to miss is that you're not going to have a robust framework for your basis of design. You're going to need your owners and your building occupants, whatever that means for each typology, to really guide you on how they're thinking they're going to use this building. Because if you don't even have that, when you start digging and making, trying to make decisions for your design, you're going to have so much uncertainty, you might not be able to move forward. Okay. So I want to highlight that out of this, you won't have a robust basis of design, a robust framework to design to, if your owner, as well as your, typology staff is not involved in the discussion from day one. They won't predict exactly how everything's happening, but their prediction is going to be a lot better than the rest of the design team, right? Us included. And then understand the industry standard practice. So this is something that maybe, again, in the Pasive House community, we know where we want to go, but when we start talking about new typologies, we don't always know where we're coming from. And if we don't have the same language, then it's going to get a little bit difficult. So what are we doing? What do I mean by understanding industry standard? It's understanding, like, what is your command ground? What is your starting point? What would happen if you weren't there? What would they design? And then once you know that, you can then separate every single design element in one of two categories. What are the design elements that I don't need to touch? Because if we do business as usual, we'll be fine. And some of them will be in there. And what are the other elements where this is where you're going to say, hey, I know you've done it like this in the past, but on these ones, we're going to need to change things. And these are the ones that we should spend time on. And that allows you to guide the team, like to have their focus on what is impacting the building energy performance and avoiding the pitfalls. So you're more or less, how would I say that? You're making your design team a lot more comfortable in merging a new typology with their existing work. You're not telling them it's so scary and we've never done this before. You're just saying, out of everything that you've done before, I have 20, 30, 50% that we need to work on differently. The rest, we keep doing what we've done. Second, use an early phase integrated design approach. Again, we hear a lot of teams out there doing, integrated design processes, but what we really mean is enhanced, more communication, more integration. The way it works is that we're moving away from the top-down approach, where more or less top-down approach to a fully circular approach, where you have everybody at the table, and the mind shift that we have to do with the design processes that we have is really set performance at the core. Performance, like the targets that you want to go to, they are in the middle of a table, and then everybody comes around and discuss about that. You don't design your building first and then check if it can meet these targets or these requirements. And for you to do that, we've had Monty's workshop on Tuesday. Yeah, it's a few days already. That was talking about like early stage integrations with like big workshops. The teams can be reluctant, but the truth is, without that integration, you will not get the maximal, cost and performance optimization out of that. And you will probably get into a few cycles of redesigns, which we don't want to, right? 3, this is where the fun begins for the energy modelers. Now that, you understand your typology and you've done an integrated design approach to start developing your design, you need to go all into some sensitivity analysis with your model. Okay, what do? You grab every single variable that you have and you move it a little bit and you see if it makes or breaks your model. I'm showing you a few examples on the screen. Like, this is already like 4 or 5 years ago for the University of Victoria commercial kitchen. And I know the graphs are not like super big. What I can tell you is the variables that we're testing are tested against the space heating demand, which on the graphs, the two on the left are moving from 20 to 40 kilowatt hour per square meter per year. So 6 till 13 kBTUs per square feet per year. And the last one is 20 to 60. So 6 till like 19 kBTUs per square feet per year, right? And if I start moving one of these variables slightly left and right, I have my model that goes completely crazy, okay? Don't be afraid to push your energy model. FYI, we had two PHPPs on that project, and we all had like 85 plus iteration in the variant sheet, and it didn't break. So you can fit more in there. And once you've done that, what do? Once you've done all your sensitivity analysis, you will be able to find your key levers. What do I mean by key levers? You want to find the big rocks, right? You're going to have to design right before looking at the gravel. And if you don't know which variable is which, you're probably not going to optimize the design approach that you have with your team. What's the goal with these big levers? What to do? The first thing we have to do is explain why what are the values that we've picked and why we're modeling it this way. And then what do we ask to the certifier and to PHI when we have these values and they are modeled? How does that relate with past projects? How does that relate with literature research? Do we know a little bit more? Because if we get these variables slightly wrong, there is a very big impact. So that's where you want to go at it with a fine comb. Quick warning. You are so far in uncharted territory by that time that there won't be a readily available answer and there won't be a very precise answer, like that exact internal heat gain with like 2 decimal places on that. It's not going to happen. So make sure that you start that discussion with your certifier and with PHI early, and you have enough in your energy budget for a buffer if things get to change, because they will change. Okay, finally, as Elena said, we've done the most hard part. Ooh. Is that me or is that you? That's not me. Okay, good. Cool. Okay, so once we've done all that, then you have to confirm your performance requirements. You've already looked at everything. You understand the big levers. You know where your design is going. So now you need to use both, no matter what, a qualitative approach of applying every single best practice, but also a quantitative approach if you have the luxury of working with a typology where you have figures and you can do calculations. Because if you don't set these targets, you literally do not have a framework to design to with your design team. And it becomes then incredibly frustrating for the design team to say, hey, Maureen, so how are we doing with the kitchen? And my answer is always, well, it depends. Where are the limits? Where are the targets? So understand that without these clear goalposts, these performance requirements that can be either just best practices or best practices and energy metrics that you have to meet, you won't have a design framework. Therefore, your team might not go, you might end up redesigning or, putting certification at risk, right? Because as soon as you've made some of these decisions, it will get harder to move backwards. To change that. 5, now that you have your metrics, now that you have your performance requirement, make sure you manage your energy budget as a team, okay? You have the levers, you have the performance targets that are set, but the truth is your energy modeler cannot be the only person understanding and speaking that language, right? You need to know what the performance targets are, but once you know that, you need both a knowledge and responsibility transfer to every single one of your disciplines. Because if you're working with a typology that we haven't done before, there's probably too much going on for the energy modeler to be the sole source of knowledge on how the team is deciding to spend their energy budgets, right? And you understand by energy budget, what I mean is like your space heating demand, your space cooling demand, your PER are a bucket. It's an allowance that you get given, and it doesn't matter how you get there. You need to fit everything within that allowance. Okay? So make sure you manage that as a team. And then, and you need to speak the same language. That's fine. And then final one, Elena already presented this one. Once all of this is done, which I cannot, overstate that it's a labor of years and so much hard work. But if you get to a point where the building is built, then commissioning and sharing lessons to update the best practices is absolutely key. Again, commissioning, you've heard it several times today. All the latest conference I've gone to as well, there's been so many different stories about either the lack of commissioning or the lack of ongoing monitoring afterwards, which has led to all kinds of discoveries. So please go get that data and share it back. And then, go back to PHI and the rest of the industry on how we improve on the guidelines. What did we learn? And can we simplify it the more we learn? Okay, we're almost there. These were very, that approach that I've just described is really for new typologies, right? Like the thing that we haven't figured out. However, we wanted as a team to give you like a few nuggets of design approaches that will be helpful no matter what, okay? Particularly helpful on new typologies, but helpful no matter what. And very quickly, yes, question the status quo, okay? Channel your inner 4-year-old self and just make sure that you question every single design decision to say, why? Do I understand? Does that still make sense in my context? Okay. So that is extremely important. It might not give you, I don't know, the best, how do you say that? The best reputation with the rest of the design team, but don't worry, you can live through it. I've done it. You can do too. 2, enable early decision making. So you've seen that graph before. You know that the longer we wait to change things, the more it costs. Okay, nothing new. But the truth is, our industry and energy modelers, we operate in that black box, and we need to push it to the yellow box. That is a lot earlier. Okay. Side note: it's easy for us to do that, but remember that you're putting a lot of your design team, like you're asking them to evolve or like to act outside of their comfort zone. You're asking them to make really big decisions way earlier than normal. So have a bit of empathy, explain clearly what you want, and then help them, ask them what they need to make these early phase design decisions, okay? Because this is not early and this is not how the industry normally works. So put yourself in both shoes to make sure it goes okay. And finally, these typologies, as not scary, but they're different. We haven't done them before. So make sure that to make everybody a lot more comfortable, make sure that you highlight what will be the pain points that you're seeing on the path ahead of you, and make sure that you share what design elements will stay, like where you can use, business as usual case, and which one you need to focus on and change things. And when you give that clarity to the team will be a lot more comfortable into doing a great job where they already know where to do a great job, and having extra communication with you on the ones that you need to work together on. So, summarizing everything we've seen today, yes, use an in-depth integrated approach. We cannot say it enough, but communication, communication, communication. Okay? When you think you've done enough, yet go one step further, because when you say A, I understand B and whatever, and it gets complicated. So do that extra work. The more you do it early, the more you're going to save down the line. Early involvement of a design team and certifier, that's obvious by now. Every typology can be approached with a similar process. If you have all these steps, it doesn't matter what gets thrown at you, you will benefit out of going through these steps, and then can decide if you can push it all the way to Pasive House, or if not. But that's where you have to go through for that feasibility study before pushing them further. And then please just make sure you reach out to the community, okay? And here's the process summarized again so that you have it, but understand the typology, integrated design approach, sensitivity analysis to get the big rocks, then confirm your performance requirement, then manage that energy budget to stay in line with the performance requirements that you have, and if you can, then commission and share all the lessons. With that, I'm going to pass it back to Elena to help us close everything and inspire us along the way.
Okay. So I guess we may have bombarded you with a lot of information about very different typologies and what you need to think about when you're doing a Pasive House. The thing we wanted to close with is there are already pilot projects or first projects out there, and you can learn a lot from them. So look around in this room, look around, or I'm positive also online, there are already people that are doing something similar to this or even cooler than this. And just to give you a teaser to sparkle your competitive self, take it as you want. We want to show you a couple of projects that have already been done in the region or that are coming up. This is not an exhaustive list. It's just the ones that we were able to collect up to now. So you probably already know the house at Bernal Tech. That is a dorm project. There's also already a very interesting Pasive House educational office in Canada. I think Peel Pasive House was working on this one. There's this very interesting community center in Clayton, which was also certified last year. Of course, you've already heard about Pirelli, this very interesting retrofit of a factory into a hotel, which was certified this year. Then there's also a car dealership that was designed to the Pasive House standard in Canada. You know already the large multifamily projects that are coming up, including this one, Sendero Verde, in New York. There's already a laboratory. This is it's called the Wood Innovation Research Lab, which is there since 2018 in Canada. We also have additional student residences in Canada that you can draw inspiration from. There's this very interesting office retrofit in Pennsylvania that is an Enerfit Plus that I recommend that you also take a look at. Of course, Winthrop in terms of large-scale projects that can achieve Pasive House. There are a couple of fire halls coming up in Vancouver. The first one, number 17, is already constructed and in operation, and we hope to get it certified this year. But there's also at least another one that is coming up that is on early design stages. There's this very interesting mixed-use building that includes social housing, a primary school, and a kindergarten, also in Canada. And this tourist and exhibition center that I believe we saw in the awards last evening. There's this, the Summerside Eco Industrial Park, also in Canada, where we have offices and also warehouses that are going to be planned to the Pasive House level. And a lot of other interesting mixed-use buildings like this one, which is an office and an auditorium for the Chamber of Commerce in Castlegar. I hope I pronounced that correctly. A couple more of the student residences that also are that have commercial kitchens in Canada. Marine can talk a lot about those if you have questions. And I mean, many more. There is a bank coming up in Canada, a town hall in Quebec. The first school is coming up in New York soon. There's an extension of a bus garage that is working with the Enerfit retrofit plan. And of course, we couldn't put everything here, but there's also tons of multifamily and single family projects that are dealing with very interesting concepts. They want to do modular building. There are high rises coming up. There's retrofitting of A-frame houses like this one here. So get inspired, reach out to the people around you, look in the Pasive House database for projects that are similar to the one that you want to do. And with that, we thank you all for your attention.
Thank you for that. That was very inspiring work that you presented. So I'll kick it off and then we'll kick it to the rest of you. You talked about synergies that are available in commercial kitchens, and I was wondering if you could talk about that in the case of hospitals. It feels like there's a million pieces of equipment, some needing heat, some needing cool, and the complexities and possibilities available in that. Whoever would.
Synergies as in a future project, or you mean like within the project trying to? Okay, waste cool. Okay, yeah. Okay, so I don't know if you can add to hospitals. I don't know to what extent that was implemented in the hospital in Frankfurt, which is the first and so far only Pasive House hospital. I know from the pool projects that is certainly something that is being used a lot. Right, there's the gym areas that are being actively cooled pretty much all year round, and then there's the pools and the pool water which need heating all year round. So that's it's a no-brainer really, but you'd be surprised that it doesn't. Like, you do have to bring it up and say, think about this, please implement this. to use the waste heat from cooling for one space to heat other parts of the building. So yes, certainly, as I said, it seems like a no-brainer. There's a lot of potential in there, but you do have to keep an eye out these things and point them out early on to the design team so that they actually get incorporated.
Yeah, I mean, there's definitely synergies there, and you're right, you have to take a look at that. But I think you also have to keep an eye on internal heat gains are free heat during the winter that you can use, but then there will also be your problem during the summer, right? So it always makes sense first to reduce the energy demand and the internal heat gains as much as possible, so have efficient processes, and then if there's some remaining heat that you can use, definitely it's there, and then it makes sense with energy efficiency, right?
First of all, I just want to say thank you. What an amazing presentation. And I think if there was anybody, I'm sure not in this room, who was doubting the depth and technical validity of Pasive House, when you hear the work that goes into new typologies, it's completely convincing. So thank you very much for that. I would just like to show that presentation to anybody that I'm talking to that's doubting what we're trying to achieve with Pasive House. I just wanted to wonder if you think there are any future typologies you haven't addressed yet that you think are on the horizon. I'd just be interested to know if what's out there that you haven't yet covered today that might be there in the future.
I'm going to say there's always more. There's always a new challenge that we can face. I think it depends, like from the international perspective, it depends always a little bit where the market is at the moment. And it's really interesting to observe and to see like the focus area here in North America in terms of where Pasive House is at the moment and where it's developing. We're seeing a lot more kind of commercial kitchen stuff here, for example, than we are in other parts of the world, whereas other countries are looking at other typologies. One that we've spoken about, I don't think we've actually implemented a project yet, but where we've received interest is ice rinks, interestingly. So we've done some feasibility studies go ahead.
Sorry, I didn't mean to interrupt you. And then definitely laboratories. There's already a couple of them out there, but then there's a lot of interest in doing Pasive House laboratories. But what is a laboratory?
No, and exactly. I was going to add the same thing with Massachusetts going really hard and really fast on the codes. They have a lot of labs and, as we call it, life science. So that one, I think, will come to us soon enough, and we're going to have to really go into the details. The other one we've seen as well have been kind of elderly supportive housing, which is almost a mix between residential and hospitals, because different spaces will have different requirements. And again, I think the potential to turn that will be like, we have some of the basis, so we should be able to tackle that fairly fast, but the complexity is definitely increasing.
I think generally the health sector is something that's really interesting, right? We have this first certified hospital now, which, as Elena was saying, like the whole ripple effect, you've shown now that it can be done that's increasing a lot of interest and showing where the way is going. And certainly a lot of interest in more typologies in that sector of the healthcare.
Hi, how are you? That was a great presentation. I'm glad you brought up life sciences. That one is a really big opportunity. There's millions and millions of square feet. And life science clients tend to be some of the most wealthy companies on the planet, also known as pharmaceutical companies. So hopefully we'll see some of them knocking at your door in the near future to do those buildings better. The question I had is, how sensitive are your criteria to different climates? Do the criteria that you develop for a pool or commercial kitchen, things of that nature, school, do they change with different climate zones, or is it not sensitive to different climate zones?
I would say that aligns with kind of the general approach that for the Pasive House, we set an energy target and then we adjust the building depending on which climate and which location it is to reach that target. Yep. So we haven't scaled the targets depending on your location and climate. That we only do that for the Enefit component approach, but generally for these typologies, we set a target for the facilities. Yep.
Yeah. Well, what I would add to that is that, especially, life science and other typologies, some of our big levers, it's really about energy management, right? Like all the equipments, how you set up your system. So in all honesty, like all the kind of bespoke ones that I've personally worked on, they haven't been that sensitive to the climate, because they've been much bigger, and the issues are mainly around the PER. Like, you still have to manage the rest. You still need a good enclosure, but I'm guessing that the tough point is more around the PER criteria, and therefore is a lot less sensitive to the location.
Question for you. This is like somewhat peripheral to passive criteria. It's a bit on the active side of things, but since you guys are all involved in commercial topologies across the border, I'm pretty curious about some of the I guess next steps where stuff's going, particularly with regards to natural refrigerants. Supermarkets made me think about that, because here in the US, the biggest progress we've made is in supermarkets. We're starting to use different refrigerants to cool down those those coolers. But for other applications, especially in Western Europe, like high lift heat pumps, like your ammonia, your CO2, your propane, all that good stuff, I'm just wondering, since you guys are in that space anyways, can you speak at all to trends that you're seeing out there and things that we could hopefully look forward to, here in the US? And if it's not your specialty, no worries. I just figure since you guys are kind of playing in that sandbox, you might be able to speak to it.
Yeah, I can.
We'll share. I think it's a big question. It's a very important and relevant question. There's a lot to say to it. I also have to say up front that I am certainly not the expert also from the team at PHI. There are other colleagues who are much more knowledgeable on this than I am. It is something that we see coming up. The question is being raised more and more, and I think it's very valid to look into it. For the supermarket, certainly I know that as part of the discussions when consulting the team, there was a lot of looking at what is the more efficient refrigerant, what is the more efficient solution to be using in this context, and it's going in the direction of kind of CO2 and propane as a solution. Do you want to share some experiences from your?
It's not exactly the question you ask, because I think in North America, the supermarket typology has been a bit shy, for sure. And also not just with Pasive House, but with any type of energy modeling we do, that like they're not the first one at the door. And so if I translate it to other typologies, at least we're moving exactly in that direction. The thing that I would say is that I think manufacturers are still playing with a few things. Like they're not necessarily... They might be working full speed into getting there. I don't doubt that, but you don't see the market shouting all these new products that will come out. But we know that the design industry keeps poking them. When are the CO2 heat pumps coming out, and this and this and that? And so I think we're moving there. On the design side and ownership side, I can tell you that we're having these conversations with every single one of our owners, and everyone is listening, understanding that, some of these refrigerants are going to be phased out. The new refrigerants that we might have might need to operate at a higher pressure to have a lower global warming potential, which means you might need to rip off your entire system, right, before you can switch to the new refrigerant and whatever. So there's a lot of future-proofing thinking that goes into that, but we're not yet completely seeing it, rolling all steams ahead, because the manufacturing side is moving a bit slower than leading the market. So it will take, I think, a few more years before we see a bit more innovation, but we're definitely going that way, just a bit slower than I would want.
All right, so I think we should thank our terrific presenters.